Hello everyone, how are you? How was your physics exam? So I am here. Just let me know if I am audible. Just there is some delay because the question paper arrived a little late. So let me know how was your exam. I can see some of you are saying it is easy, some of you are saying it was difficult. Okay, now so if you can hear me, please let me know how was your exam, and I am going to discuss all the questions from your Bangalore South question paper. That is what we are located at. So this question paper I am going to discuss. If you are appearing from any other districts, how was your paper, how is the question paper, please let me know in the comment section, live comment section. I will try to reply as much as possible. So this is the MCQs. I will first solve the MCQs, then I will be solving the numerical questions, and theoretical questions I will discuss in the later part. So first, the law governing the force between electric charges is called. The law governing the force between electric charges is Coulomb's law. So no doubt about it, it will be Coulomb's law. Next is the vector product of torque acting on a dipole of a dipole moment P vector is given by P cross E. I discussed it in my yesterday's MCQ video. The capacitance of a parallel plate capacitor can be increased by decreasing the area of the plate, increasing the area of the plate, decreasing the dielectric constant, increasing the separation between the plates. So capacitance of the parallel plate capacitor can be increased by increasing the area. If you increase the distance, then capacitance will decrease. If you decrease the area, it will decrease, and if you decrease the dielectric constant, again it will decrease. Next, electric field inside the cavity of a conductor is zero. This is known as electrostatic shielding. I have discussed this question multiple times. Kirchhoff's current law is an illustration of what? Conservation of linear momentum, conservation of charge, conservation of angular momentum, conservation of energy. It is conservation of charge. Kirchhoff's current law is conservation of charge. Kirchhoff's voltage law is conservation of energy. Now, next set of questions. Ohm's law is valid when the temperature of the conductor, exactly the same question I did yesterday. So it is valid when temperature is constant. SI unit of current density. SI unit of current density, again I have mentioned it multiple times. Current density is given by current divided by area. So it will be ampere per meter square. Full easy. Alina is saying full easy. Yes, easy. Sir, fifth is A. Fifth question, someone is saying A. What is fifth question? Let me check it once. Kirchhoff's current law, illustration of linear momentum. Are you crazy? So fifth question is B, not A. Maybe your question paper is different. Okay. The magnetic field at the center of a circular current carrying loop of radius small r is directly proportional to magnetic field at the center of circular current carrying loop is inversely proportional to 1 upon r at the center case. So where you r gets cancelled, it will be inversely proportional to only r. The resistance of an ideal ammeter is the resistance of ideal ammeter is 0. It is not small, it is 0. Identify the wrong statement among the following options about magnetic field lines. They form closed loop. So first of all, you have to identify the wrong statement. That means 4 are correct, 3 are correct, 1 is wrong. They form closed loop. So yes, it is a correct statement about magnetic field lines. The tangent drawn at the magnetic field line at any point gives the direction of magnetic field at that point. Yes, this is also correct. They can intersect each other. No, this is not correct. So that means that will be our correct answer. Outside the magnet, they go from north to south pole. This is also correct statement. So only incorrect statement, they can intersect each other, which is not possible. The given figure represents a material which is, so as you can see that here the magnetic field lines are weakly repelled, right? So this is getting slightly repelled because of the repulsion. It is going outward. If it was going inward, that means attraction. Very strongly attraction means everything will be inside the material. But this is a slight repulsion, that means it's a diamagnetic material. This is a diamagnetic material. The principle behind the working of an AC generator is electromagnetic induction. Very simple. This question also I have discussed yesterday, right? Sir, PU1 physics exam is on Monday, sir. Please help, sir. Please, how to prepare, sir? Please help, sir. Sumit, I will try to help you as much as possible. I have made one video on important questions. You can go and check that out. Solution, if not possible, at least some important questions I will try to discuss. In series LCR circuit, when XL is greater than XC, the average voltage is leads the AC current. So if XL greater than XC means circuit is in inductive mode, and they have asked about average voltage. So in general it is given in terms of current leads, current lags, but here they have just reversed it. So average voltage will be leading, current is lagging. If XL is greater than XC, that means it's an inductive circuit. In case of inductive circuit, current lags behind voltage, that means voltage will be leading. That is a slightly same question, but they have changed the language a little bit. So voltage will lead the current. Voltage leads the current. So this is a very interesting question. So you may make a mistake here because it is just inverted. If it was given as a current, average current, then it would have been your common question. Current is lagging behind. Current lag means voltage leads. Okay. Which of the electromagnetic waves used to detect forged document? So forged document is always detected using UV rays. Okay, forged document is always detected using UV rays. If you put UV ray on a for example currency, okay, currency has some UV lamp markers. Okay, if you put UV light on it, the markers will be visible. If it is a forged currency or forged document, those markers will not be present. That's how you can detect whether it's an original document or a duplicate document. Okay, UV rays are used to detect forged documents. If XV, XX and it will be lambda X. Sorry. Okay, there is some slight printing mistake. Lambda V, lambda X and lambda M represents the visible light, X-rays and microwaves respectively. Then which one will be greater? So in terms of wavelength, microwave will have the highest wavelength and X-rays will have the smallest wavelength. Okay, visible light will be in between. So lambda M greater than lambda V greater than lambda X. So correct answer is option B. Very interesting but easy question. If you have understood the concept of wavelength and frequency, then you should be able to answer this question. Now I think the fill in the blanks part is not given anyway. Fill in the blanks was anyway easy. Let me go back to the numerical questions. Two positive charges, 9 nanocoulomb and 4 nanocoulomb. Those who still have their physics exams, they should check out these first two questions. They are not super common, but not difficult, but not super common. Mathematically easy. If you have even calculated the electric field due to individual charges, you will get some marks. Vector addition is also not difficult. But let's see. Two positive charges, 9 nanocoulomb and 4 nanocoulomb, are placed at the points A and C respectively of right angled triangle ABC, in which angle B is 90 degrees. AB is equal to 3 centimeter, BC equals to 2 centimeter. Find the magnitude and direction of the electric field. Here one thing is missing, at where? So it should be magnetic field at B. Okay, this is the question. This at where you have to measure the electric field, because different points will have different electric field. So this part is missing in the question. It should be at B. So here we have a right angle triangle. This side is 3 centimeter. This is 2 centimeter. This is angle B. This is A. Here we have 9 nanocoulomb. And here we have 4 nanocoulomb. We are trying to find electric field at this point B. So first of all, you have to understand that both charges are positive. Both charges are positive. So electric field due to A will be this direction. Electric field due to C will be in this direction. Okay, and the resultant will be somewhere in between. So that's what we will do. Wait. So first of all, electric field due to A. Electric field due to A will be given by K QA by RA square. Okay, now let's put the values. K is 9 into 10 to the power of 9. Q is 9 nanocoulomb, so 9 into 10 to the power of minus 9. And the distance here is 3 centimeter. So 3 into 10 to the power of minus 2 whole square. Okay, now simplify. You will get 9 into, now 10 to the power of 9, 10 to the power of 9, minus 9 cancels. So 9 into 9 divided by 9 into 10 to the power of minus 4. One of the 9 will cancel and you get 9 into 10 to the power of 4 Newton per coulomb. Now let's calculate EB. EB will be KQB by RB square. I will take some comments after I solve the questions. So, and if your physics exam is not yet over, I request you to check these type of questions which are I consider is slightly tricky, not super difficult but slightly tricky. Divided by 2, sorry, this is not 9, this is 4. Okay, 4 into 2 into 10 to the power of minus 2 whole square. So it will be 9 into 4, obviously they cancels, and we get 4 into 10 to the power of minus 4, 4 cancels, and we get 9 into 10 to the power of 4 Newton per coulomb. So if you see that both electric fields are equal in magnitude. So EA and EB, they are of equal magnitude. That means two vectors are, first of all, they are perpendicular because this angle given here is 90 degrees. Right? So this is the point B. So angle B here given as 90 degrees. So this angle is 90 degrees means this is the opposite angle. So this will also be 90 degree. So two equal vectors, they are at right angle. So their magnitude is very simple. So their magnitude is given by the net electric field. You can take any EA or EB, both are equal magnitude wise. So you can take that EA root 2. Okay, EA root 2 will be when two equal vectors at right angle, their magnitude is given by any magnitude of any one of the vector times root 2. So that is that. So just put 9 into root 2 into 10 to the power of 4 Newton per coulomb. This is the resultant magnetic field. Now what about the direction? Direction, as you can see, both vectors are equal, so it will be at an angle 45 degrees. Okay, it will be at an angle 45 degrees. So you can say that this is along the angular bisector of the angle B. So along the angular bisector of angle B, and it is outwards. This is a shortcut. You can mention this angle also if you want 90 degree plus 45 degree. You can mention any one of the angles. Both angles will be equal. Okay, no differentiation there. So either you can mention the angle, or you can say that this is along the angular bisector. This is not the median, by the way. Okay, angular bisector, if this sides, two sides are equal, then only it would have been the median. Otherwise it is not the median, it is only the angular bisector. Okay, it is along the angular bisector because this is a 45 degree angle. So this angle 45 means this is also 45, this is also 45. So it is called angular bisector. Okay, any doubt in this question, please mention in the comment below. Did you get the correct answer or not? Sir, PU2 exams, CU, I don't understand. Blue entity. Hi, Alish. PU2 exam, CU, UK. What to do? I don't know. What is your meaning by that? UK may be your district code. Sir, can we use 2? Yes, 2e cos theta. Yes, you can use that. So 2 cos theta means here you will get the same answer. Okay, you will get the same answer because it will be cos 45, because the angle is, both the vectors are same. That means it will be along the 45 degree angle. So cos theta's value is 1 by root 2. 2e cos 1 by root 2 is e root 2. Okay, same thing. Srinivas is saying manageable to pass for 25. 2e cos theta by 2 y theta by 2. Yes, cos theta by 2, yes, 90 degree by 2, yes, correct. Okay, no problem. Even if you have just only written the directions incorrect, 1 mark will be deducted. If you have solved the problem exactly as it is, as I solved it, if your answer is same, you will get 4 marks. Only direction, 1 mark is there. Okay. So if I revise my syllabus by your video, it will be enough. Portions are first 8 chapters. Extreme Gaming YT. I have, yes, if you are watching all the videos, I have done one numerical video, one MCQ video, then we have also done quick revision video. There are some long form videos also where I have solved some questions. If you see all those videos, definitely yes, but even if you watch at least few of them, that will be also good for you to score good marks. Okay. Navya, sir, how I can't understand, can you teach again the previous question? Which one you are talking about? Dhanu sir, for first PUC we are in the process. I will try to make some video, at least a quick revision video. Navya, which question? Previous question, MCQ. Sorry, the numerical question. So numerical question, first of all you have to calculate the individual electric field. I think this much is clear, right? I hope you have understood that, right? So first you have to take 2 points and put the charges accordingly, and if you do that, you will realize that the electric field due to A and electric field due to B both will be equal in magnitude. Both will be equal in magnitude, right? So EA and EB both will be equal in magnitude. This type of questions we have solved, not exact this question, but similar questions we have solved when the magnitude wise electric fields are same, right? So two electric fields are same, and both electric fields are away from this point. Why away from? Because both the charges are positive. So if it is a positive charge, electric field will be along the line joining the point and the charge, and it will be away from. So this is the direction of electric field due to EB. Similarly, electric field due to A will be away from A, and it will be again along the line joining. So now this angle is given as 90 degrees. So by geometry, this is an opposite angle. So opposite angles are equal. So that means if this angle is 90 degree, this will also be 90 degree. This much is clear. Now because both are same magnitude, the resultant will be along the angular bisector. Okay, it will be along the angular bisector. Someone was saying another formula which he used, which is 2e cos theta by 2. That is also fine. Okay, theta is here as 90 degrees. So 2e cos 90 by 2, or you can use the old formula of E net equals to square root of EA square plus EB square plus 2EA EB cos 90. Whatever formula you use, you will always reach at this result. Okay, if you use this also, cos 90 is 0, so this term will be 0. So EA square and EB square both are equal in magnitude, so they will be common. One of them will be common and come out of the square root, and you will get them as EA, and 1 plus 1 will be inside the square root. So 1 plus 1 is 2, so root 2. So whatever method you use this one, you use this one, or you use the shortcut method. If you have the knowledge, you can use this shortcut formula. So whatever method you will use, you will get this result. Okay, right? Navya, I hope you understand. Right? Now the angle, as I mentioned, angle you can say that it is along the 90 degree, because it is both vectors are equal in magnitude. It will be along the angular bisector. Okay, angular bisector means the line which separates the angle into two equal halves. That means 45, 45. So this is along the angular bisector of the angle B. Okay, and it is outward. Why outward? Because it is going outside, it is not going inside, right? So that's why I have mentioned Angular bisector can have two directions. One is inward direction, one is outward direction. It is outward direction. Okay, so that's what how you have to mention the direction. If you make a mistake in the direction part, it's fine. If you have solved all the electric fields and calculated the net electric field, 1 plus 1 plus 2, you will get 4 marks. This is 1 mark you will make, but make sure you have put the units also. Otherwise, 1 mark, another 1 mark will be deducted. Right? Clear now? Yes, second numerical I am solving. Point charges of plus 2 nanocoulomb, 4 nanocoulomb. I hope there is no plus given here. That means it is also plus. So this is one problem with the district papers. They mention plus 1 and do not mention any sign somewhere. Okay, that is one of the issues. So point charges plus 2 nanocoulomb, plus 4 nanocoulomb and plus 8 nanocoulomb are placed at the corners of ABC respectively of a square ABCD of side 0.2 meter. Calculate the work done in moving a charge of 2 nanocoulomb from point D to the center of the square. I think I solved this during one of my lectures. Similar question, not exactly the same question. During my electric potential and charges electric potential and capacitance chapters question answer, that direct chapter question answer, not in the numerical video, but I have solved this once. So what is the charges given here? So let's see, this is A, B, C, D. Okay, so charges are given plus 2, then we have plus 4 and plus 8. But potential, if it is a potential, it is easy. It's not super duper difficult. All the sides are of 0.2 meter. Okay. Now we have to calculate the electric field, electric potential due to all the charges at this point. Now if you see that charge A and charge C are at a distance of 2.2 meter. Both charges are. But this charge is not at a 0.2 distance. It is a somewhat different distance, which is 0.2 root 2. This is the diagonal of a square, right? We are trying to move this charge from D to the center of the square. Center of the square, say O. Okay. Now for this, what we have to do? We have to find potential at point D and potential at point O, and then find the difference between them. Final minus initial will be the work done. Now for that, we have to calculate potential due to this and this as well. So potential is a scalar quantity, by the way. So you just simply have to calculate and add this. So first we will calculate the initial potential, say VI. VI is basically VAI plus BI plus VCI. That means initial position and all three charges, right? So what is K Q A by R1 square, R1 not square, sorry, plus KQB divided by R2 plus KQC divided by R3. Okay, let's see what are all the charges and what are the K is common. So let's put the values. QA is 2 nanocoulomb, 2 divided by distance from this charge is 0.2 plus QB is plus 4. Now why I am not putting nanocoulomb 10 to the power of minus 9, we will take that as common. Okay, so 0.2 root 2 plus it is 8. So 8 divided by 0.2, and as promised 10 to the power of minus 9 is taken as common. All the charges are nanocoulomb, so that's why it is taken as common. Now K is 9 into 10 to the power of 9, and I can take this 0.2 common as well. So division by 0.2, 10 to the power of minus 9. Now let's see what is inside. So we have 2 plus 4 by root 2 plus 8, right? So 2 plus 8 is 10, and we get 10 to the power of 9, 10 to the power of 9 cancelled, and it will be 45. 9 by 0.2 is 45 into 10 plus I can write it as 2 root 2, right? Now you can simplify this, no issues. I will try to calculate the V final as well, and then we will try to find the difference. So this is the V initial. Now let us calculate the V final. V final formula will be slightly tricky. So it will be K into, K is common, QA by the distance will be different. So let's say R1 dash plus QB, R2 dash plus QC, R3 dash. And one thing you will see that in the central case, all the charges are actually equidistant. So this will be 0.2 root 2 divided by 2. This will be also 0.2 root 2 divided by 2. Okay, every distance will be 0.2 root 2 divided by 2. Why? Because this is the central point, right? So all the charges are at same distance. Okay, so distance will also be common. In fact, so that's why I will take the distance common as well. So this will be my new R dash, and I just simply say QA plus QB plus QC. Okay, now we will apply the same method. 9 into 10 to the power of 9 and 10 to the power of minus 9 common from all the charges. So 2 plus 4 plus 8. Okay, divided by, now the distance is 0.2 root 2 divided by 2. Okay, so this is cancelled, and we get this as 18 divided by so 45, 90 divided by root 2, and here we have 14. Now you have to calculate these two values and find the difference. I don't have a calculator over here, so you can calculate it and let me know the value. So what is the work done? Work done is VF minus VI times the charge. Charge here given as 2 nanocoulomb. So whatever value you will get, you have to finally multiply with the 2 nanocoulomb charge. That's how you can calculate. Now let me someone please calculate it and tell me the value, please. Sir, will we get grace marks for the 42nd question because it is not mentioned where to find the electric field? No, Vishnu, no. It is very clear, only one point where you can find the electric field actually. What's your opinion of the question paper? Tough or easy? It is not very tough, not very easy. It's a slightly medium paper, I would say. Slightly difficult if you consider in terms of board level paper, but last year board paper also there was one typing error. They did not give any grace marks. Okay, there was one serious typing error, but they did not give any grace marks for that. So, and this is also very standard question, so they will not give any grace marks for sure. Thank you, Navya. Okay, now you can calculate it using your calculator. I generally do not prefer to use calculator. That's how I always tell my student, don't use calculators. But in board exams, there is no other option. You have to use a calculator. And in this case, I don't have access to calculator. This is the method. Very simple, straightforward method. No rocket science in here, right? Just you have to calculate, do the step-by-step method, and finally calculate the work done. Work done is difference in potential, final minus initial, always this is the case, times the charge which is given in this case, right? I am leaving it here. If you want the exact answer, I will ping it you later on. Please let me know. And this is a circuit based question. This is very interesting question. From offset it might look like a Wheatstone bridge. Actually it is not a Wheatstone bridge. So they see that 5 2 there is a resistance in between, so current can be 0. Actually it is not, because there is a battery and battery has an internal resistance, and internal resistances are not same. So you cannot simply apply Wheatstone bridge principle. So I1 current is passing through this, say I2 current is passing through this, and total current I is passing through this. So I equals to I1 plus I2. Okay, this is one thing. And also first we will use the loop, this loop, and I generally prefer to use the direction which the battery is trying to send the current. So if I1 current goes in this direction, I1 current will always come back. Remember this. So for a battery, whatever current is exiting the battery, the same amount of current will always come back to the battery, no exception. Similarly, I2 current is going out of this battery, that means I2 current will go back to the same battery. Why I am doing that? Because there are two resistances on both sides. So if I1 current passes through 5 ohm, then I1 current will also pass through 2 ohm. That is the major thing. Okay, similarly, if I2 current is passing through this 5 ohm, same I2 current will pass through this 2 ohm as well. And not only that, there is an internal resistance as well. The internal resistance will also have the same current I1, and in this case I2. Clear? The current through these two resistors will be same along with the internal resistance. Similarly, current through these two resistors and internal resistance will be same. Any doubt in this? If you have any doubt, please ask me. Now I will show you how to solve this kind of question. This is not an easy question, by the way. Always I say that current electricity related questions are not always easy. You have to use a lot of mathematics. You have to apply and practice this kind of questions, then only you will be able to solve. There is a high chance you make a small mistake. Even if you have initial equations are correct, if you make a small mistake in between, you will only get 2 marks. For the first 2 equations correct, you will get 2 marks. Otherwise, you will not get any marks for making in between mistakes. Other questions, on the other hand, even if you make mistakes in the middle, there is a high chance you will get part mark. That's why I say if it is related to circuit diagram, better to skip it if you have not practiced these questions. So I1 current passing through this 5 ohm. So 5 into I1. 5 into I1. Next, as I said, I will always like to take the direction of the loop in the direction of the current sent by this battery. Okay, so I am using this loop. This is one loop and the second loop is this one. Okay, these two are the easiest loops. So for this loop, 5I1 plus 10I plus 10I. Okay, plus 10I, then we have again 2I1, and lastly but not least this 1 ohm, which is 1 into I1. Okay, so if you add and that should be equals to the EMF of the battery, that is 2. Okay, this is how you always construct a circuit theory related questions. So 5 plus 2 is 7, 7 plus 1 is 8. So 8I1 plus 10I equals to 2. Okay, and if you divide everything by 2, you get 4I1 plus 5I equals to 1. Now this is not over. This is not over. Even if you have to find I, there is another relation, which is I equals to I1 plus I2. If you apply Kirchhoff's current law at this junction, I1 current is from top, I2 current is from down. So together they will be I1 plus I2. So you have to put that value over here as well. So I1 plus 5, I1 plus I2 equals to 1. So 4 plus 5, 9I1 plus 5I2 equals to 1. So this is the equation number 1. Okay, 2 variables, 2 equations you have to construct and then solve them. That is how you should do it. Next, we will apply the same principle in this loop, down loop. Okay, now we are considering this down loop. Okay, I2 current is passing through this 5 ohm. So 5I2 plus 10I. Again we are going in the direction of current, so everything is positive. One advantage of taking this direction is that if there is no invert in between the circuit, then everything will be positive. That is one advantage of using such method. So I2 into 5, okay, 5I2 plus 10I plus 2I2, and last but not the least this 2I2, and that should be equals to the EMF, which is 4 in this case. Okay, now again 5 plus 2 is 7, 7 plus 2 is 9. So 9I2 plus 10, instead of I will put I1 plus I2, and that is equals to 4. Now add them, you get 10I1 plus 19I2 equals to 4. So this is the equation number 2. Okay, so this is the equation number 2. Now you have to solve these two equations. As you can see, this is not a simple solution. You have to multiply. Let me multiply this. Eliminating I1 seems easy. So multiply equation number 1 with 10 and then subtract equation number 2 multiplying 9, what we get. So 90 I1 plus 50 I2 equals to 10, and here we got 90 I1 plus 19 into 9. 19 into 9 means 81 plus 90, 171. Equals to 4 9s are 36. Now you have to subtract them. Plus minus is fine, even if minus is coming, it will come on both sides, so no issues. You will get minus 121 I2 equals to minus 26. So minus minus will cancel and you get I2 equals to 26 divided by 121. You have to use a calculator to find the exact value, and then you have to use this value in any one of the equation and calculate the value of I1, and then last step is to calculate I as I1 plus I2. Okay, this is the final answer. So as I mentioned, even if you have constructed the equation properly, if writing these two equations, you get 1 mark. Otherwise, after solving, even if you make a small mistake anywhere in between, there is a high chance the marks will be deducted, and not always the answer looks pretty. As you can see here, this is not a JEE exam or not a KCET exam where all the data are given such a way they will cancel easily and you will get a pretty answer. The answer does not look pretty here. There is one question given in your sample paper also, that is also not looks pretty. Now I think 43, 44, 45. This is the last question. This question is much easier. Exactly standard question from the chapter alternating current, and not only that, you will get part marks for calculating everything. Okay, so if you want to calculate impedance, anyway you have to calculate inductive reactance and capacitive reactance. Only drawback of this chapter, you have to use calculator for every step. Otherwise, this chapter questions are very straightforward. So first, a circuit has 50 ohm resistance, 0.3 Henry inductor of resistance 2 ohm and a capacitor of 40 microfarad connected in series with 240 volt 50 hertz power supply. Now here, inductor of resistance 2 ohm means, actually it is not, I am not sure what they are trying to say, inductor of resistance 2 ohm. Maybe it is the resistance of the wire. So in that case, you have to add this resistance back to this 50 ohm. Okay, inductors, when you calculate inductive reactance, this resistance is not important. This resistance will be added to your net resistance. So net resistance of the circuit is 50 plus 2 due to the inductor, so 52 ohm. Even though this is a very uncommon structure, in the board exam you will expect more standard question paper that this resistance is generally not given. In case you see any resistance given to inductor or capacitor, that you have to add directly to the resistance of the circuit. Now what is the inductive reactance? Inductive reactance is given by 2 pi f into L. 2 pi f into L. So 2 pi f is given here 50 hertz. So 50 and L is 0.3. So it will be 100 pi into 0.3, that is 30 pi. 30 pi means 93, approximately 94. Approximately, you can use the calculator to calculate the exact value. Okay, so approximately 94 volt, 94 ohm. What is XC? So this is part A, inductive reactance. Capacitive reactance. Capacitive reactance formula is 1 by 2 pi F into C. Okay, so F into C, let's put the values. 1 by 2 pi into 50 into C is given here as 40 microfarad. So 40 micro means what? Micro means 10 to the power of minus 6. So 10 to the power of minus 6, why bother? We will put that in the numerator as a positive. Okay, we like everything positive, that's why I have put 10 to the power of 6 in the numerator. Now 2 into 50 is 100, 100 into 40 is 4000. So 4000 pi and 10 to the power of 6. So 3 zeros will be cancelled and we get this as 10 to the power of 3 divided by 4 pi. So that's what I said. If you want to calculate the exact value, you have to use a calculator. It will be approximately 15 or 16. Okay. So 3 5s are 15 and 3 2s are 10, 200, and it will be 66.66, I think. Right? Yes, 66.67 ohm. So this is the capacitive reactance. Now impedance, what is impedance? Impedance is given by the formula square root of R net square plus, here this is a rare case where XC or XL and XC, not rare case, sorry, XL and XC's value is bigger, so XL will be first minus XC. In case XC's value is bigger, don't worry, first of all there is a square sign, so the negative sign will not impact anywhere. Okay, if you want convenience, you can put the bigger value first, smaller value second, does not matter. Now you have to calculate this value R net. For this question you have to use 52 ohm, otherwise they will deduct 1 mark. Okay, not much, but 1 mark will be deducted. Next is phase difference between the voltage and current. Phase difference is tan inverse XL minus XC. Again, in this case, whoever is bigger, that will be first, whoever is smaller, that will be second. Okay, XL minus XC divided by R net. Again, if you don't want to calculate the exact value, you can leave it in this case. Otherwise, tan inverse, you have to calculate tan inverse, you have to use tangent table. No need, even if you leave the answer as tan inverse, okay, I think 28 divided by 52. Okay, simplify this whatever possible, how much it is possible, you will get full marks for that. Okay, now, and any other question you want me to solve, please let me know. Mallikarjun, first PUC we will solve, we will try, please. Which question? Sir, for numerical 2, can you please tell the final answer, please, sir? Wait, just let me check. This one, right? Answer matching is very bad habit for you. Let me check. This is 40, okay. 10 plus 2 10 plus 2 root 2. So it will be about 5577.3. Okay, and this will be $90 into 14 divided by 2, it will be 890 point, okay, it will be 891 approximately. So now let's see what is the delta V. Delta V is V final minus V initial, which is 891 minus 577.3 minus 577.3 It will be 313.6. Okay. Now you have to multiply it with 2 nanocoulomb. So it will be into 2. So it will be 6 to 7.3 nanojoules. Okay, either this, or if you want you can write this as 6 to 7 into 10 to the power of minus 7 joules. Okay, anyway you are comfortable, both are fine. Okay, now tell me if your answer is correct or not. You are getting 890. 890 is coming for this one, second one only. 650. Yeah, 650. I think maybe I have made some mistake. Otherwise, 650 is also very close. Maybe you have done approximation at the beginning only. That's why I have done, see, everything. If you put the approximated value at the beginning, then in that case you might get 650. Otherwise, if you put the value at the last stage, then it will come out to be around 627. Okay, 627 and 650, I think 10% difference is there. So it is fine. It will be considered as fine. If you get 890 joules, then maybe there are some possible mistakes is there. Okay, 890 is coming for the second one only, 891. This is the second final potential only. Initial potential maybe you have not calculated. That could be a possible reason. Okay, so from D to here means, first of all, D means this is the initial potential. Okay, at D the potential is Vi and this will be Vf. Okay, so Vf minus Vi you have to do. Maybe you have not done that. That's why your answer is coming different. 820, maybe you have made some calculation error. Okay, maybe you have done some calculation error. That's why you are getting 820. 820 is not correct. 45 root 2 into 14. Let me check it once more. Fine. 10, 45 root 2. Let me see. 45 root 2 into 14. This is fine. Calculations are fine. Only if you have made some mistake in the calculating these values, then there is a chance that your answer will be wrong. And always remember this, whenever you are solving the numericals, try to do the approximation or calculation as late as possible. For example, I have written this, I have taken all the values which are possibly common. Okay, that's how you can reduce the burden of calculation as much as possible. If you do 2 by 0.2, that is 10, then 8 by 0.2, which is 16. So if you do that in each step, there is a possibility of making mistakes in each and every step. Okay, if you make a mistake over here, then that mistake will continue throughout the problem. But if you have taken everything common, there is a very less chance of making mistakes. So only last stage, only after reaching over here, I did apply calculator. So if you try to use your application of calculator in each and every step, by this way not only your competitive exam compatibility improves, but also your mistakes of habit of making mistakes also reduces. Anyway, this is a midterm exam, no big deal. Even if you have make small mistakes, you have to learn from that and you have to improve on that. Any other numerical question you want to discuss, then I can discuss that. I think that 2-3 mark numericals are easy. Question paper wise, as I said, it is not super easy question, definitely. For example, they have given mention to limitations of Coulomb's law, not Ohm's law, but Coulomb's law. Okay, Coulomb's law is not valid for Coulomb's law is only valid for Number 1 static charge, number 2 point charge. These are some of the limitations of Coulomb's law. There are many other Coulomb's law. Coulomb's law is not applicable for relativistic cases. It is not applicable for quantum mechanics, but those are very higher level physics. Only either if you can remember it, then only it is fine. Otherwise, you never heard about relativistic physics, 99.9% of you, and quantum mechanics. Quantum mechanics maybe you have heard, but you are not sure what is quantum mechanics. So those 2 points you can skip, but the Coulomb's law is not valid if its object is enlarged, or the charge is not a point charge, and it is also not valid if charge is moving. These 2 cases are very common, okay, for moving charges, and for not point size large object, extended object, Coulomb's law is not valid. So these are the 2 limitations of Coulomb's law. Next, potential difference is applied between 2 plates of separated by 1 millimeter. Find the electric field intensity. So dV by E is equal to dV by dl. So from there you can easily find the electric field. This is an easy question. Right, any 2 properties of equipotential surface, I have given this multiple times. Define EMF and potential difference. So this is slightly tricky. EMF is the exact voltage between the plates when no current is flowing, whereas potential difference is the difference between 2 points in a circuit. It can be across the cell, it can be across a resistor. Okay, potential difference is more general. EMF is only for the for a cell, okay, or some generator. Next is, what are ohmic and non-ohmic devices? I have discussed as a part of limitations of Ohm's law. So ohmic devices are which obeys Ohm's law, that is I is equal to V is equal to IR, and non-ohmic devices which does not obey Ohm's law, for example semiconductors. Next is, draw the magnetic field lines for a bar magnet and solenoid. Both are same anyway. I don't know why they have given it. Easy diagram, okay, super easy if you have drawn it. State and explain Lenz's law. Again, common question, came from my suggestion as well. What is the displacement current? Write the expression for the displacement current. This is from EMF chapter, one of the question from this chapter. Next is, write the basic properties of electric charges. Again, very common question. Deduce the variation of J is equal to sigma E. Another easy question where the symbols have the usual meaning. So you can start from Ohm's law and just simply do the derivation. Very easy derivation. Explain with the circuit diagram how to convert a galvanometer into voltmeter. Again, very common question. Define magnetism, magnetic intensity, magnetic susceptibility. Just definition. If you have memorized it, you can answer it. Derive the expression for magnetic field at a point on the axis of a long solenoid. Now this is a something new question. Okay, this derivation never came before, so this is a new derivation. I will try to incorporate that in my future videos. Distinguish between diamagnetic and paramagnetic materials. Again, very common question. A current in a coil falls from 5 to 0 ampere in 0.1 second. So calculate the induced EMF in the coil if its self-inductance is 5 Henry. Very easy question. Epsilon is equal to L di dt. I was doing something like in my yesterday's video. So just di is 5 and dt is 0.1. L is given 5 Henry. You have to calculate epsilon. Excuse me. Very easy question. Obtain an expression for resonant frequency of LCR circuit. This is also I have done multiple times. Easy question. State and explain Gauss's law. Obtain an expression for electric field due to an uniformly charged infinite plane sheet using the Gauss's law. This question never came in the boards. First time they have given in midterm exam. You can expect such questions, but this question never came in the board exam before. Maybe this year it might come, so we will practice this as well. Next is, derive an expression for electric potential due to an isolated positive point charge. The most common and most asked question. Two cells of different EMFs and internal resistance are connected in parallel. Find the expression for equivalent EMF and internal resistance. So this is the cells in parallel. Derive the expression for force between two parallel current carrying wires. Hence define ampere. This is also the most common question, right? Define mutual inductance. Deduce the expression for instantaneous EMF induced in a coil rotating in a uniform magnetic field. So this is the AC generator question that also I have discussed and I have given the answer, right? Most of the questions are common except few. For example, this is one of the major question which generally do not come in previous year paper. So this was given in the midterm, and in the midterm question paper you will expect some of the questions which are not common. Overall, as I said, question paper level was not super difficult. It was relatively easy, but yeah, not very common like you expect in your board exam. Board exams, most questions are actually common except MCQs. MCQs can be slightly tricky. This year paper MCQs, 1 or 2 MCQs are slightly tricky, otherwise remaining questions are simple, straightforward. Numerical portion, always there will be surprises. You have to prepare hard for numericals, okay. One day preparation of numerical is not enough. So if you want to score well, you have to practice more and more numericals. I will bring more numericals in future, so do check that out, right. Sir, 22 answer please. 22, okay, let's see 22. Which one is 22? Potential difference 0.2 volt is applied. So the formula is E equals to dV by dl. Minus sign you can skip it, okay. Magnitude of electric field intensity, basically they generally ask magnitude, but they have given the potential difference. Direction is not mentioned, so I am not using the negative sign here. dl is given 1 millimeter. 1 millimeter means 1 into 10 to the power of minus 3. So it will be 0.2 into 10 to the power of minus 3, that is 2 into 10 to the power of 2. Okay, so this is the answer. 2 into 10 to the power of 2 Newton per Coulomb, right? Any other question? Negative sign you can use, you cannot, you can skip that as well. If you say this is the magnitude, then negative sign is not needed, because the direction of potential difference from which plate to which plate is given, that is not provided, okay. So based on that you can calculate it, otherwise magnitude is correct, okay. Sharag, Shivangi is saying 3 mark, okay. 3 mark numerical, I almost solved it, okay. That is the easiest. It is actually not a 3 mark numerical, okay. So here current, change in current is 5 minus 0, that is 5. Again magnitude, okay. Magnitude we are calculating, magnitude of EMF. L value is given 5 Henry. So 5 into di is this, dt is given as 0.1 second. So just put the values, 5 divided by 0.1, so it will be 250 volt. So answer is 250 volt, okay. So induced EMF is 250 volts, right. Sir, current electricity, sir, can you please tell the formulas for KCL and KVL, sir? Please, sir, tell the formulas. So KCL and KVL you want. So this is the equations. You are asking about this question particularly. Sir, for Bangalore North, can this paper, some of the questions will repeat? Yes, there is a high possibility. Some of the, because there are not super many questions, except numericals, there is a chance, and MCQs I would say, okay, there is a chance of these questions might getting repeated. Question pattern wise, for example, you can practice the questions where you are trying to find the electric potential due to a rectangle, electric field due to a rectangle, on the corner of a rectangle, or this is the new question, brand new question, okay. Generally there is a rectangle based question, generally we have solved multiple times. So that rectangle based question, you go and check that out. And in case of potential also, rectangle square based question you can check, okay. These are the type of the question. Exact values, data will definitely be not the same, okay. Otherwise derivations are can come, obviously. Along with that, there are other common derivations as well. They are not given, those you can check them out. This derivation, there is a less chance of coming this derivation, but other question there is a high possibility some of the questions will be repeated, okay. Nandan, let me show you the equations. So these are the equations. So you have to take I1 here and I2 in the down, okay, and you have to construct the KCL and KVL. First of all, KCL is only applied at this junction, okay. KCL is only applied here. So I equals to I1 plus I2, That's it. KCL is done. For KCL, you don't even have to write anything. If you have to show the circuit in your paper. Okay, you have to draw this circuit diagram in your answer paper, and if you show the currents properly, you don't need to write any single language about KCL. So KCL is I is equal to I1 plus I2. Okay, KVL is somewhat tricky, and always remember that what I say, whatever current exits the battery, same current enters the battery. That is always true. This is the conservation of charge. Charges are always conserved. So whatever current exits the battery, same current will enter it back from the behind. That means 5 ampere will have I1 current. This 2 ohm will also have a same current I1, right? So I into 5I1 plus 10I plus 2I1 plus this 1I. So don't ignore this 1 ohm. This is also very, very important because it has some internal resistance, and 99% students will ignore this 1 ohm. I am sure of that. Okay, so you have to be careful about this internal resistance, and then you have to just simplify it. Put I equals to I1 plus I2, create two equations, simplify them and solve them. Okay. This kind of questions are not easy, especially after solving it. It does not give you satisfaction for one thing. Okay, even after solving it correctly, you might think that okay, maybe my answer is wrong. That is one thing, because after doing all the hard work, I got 26 by 121, which does not look anything pretty. And then after solving this, you have to use this value in one of the other equations to get the value of I1. So that is one more thing. Okay. So, but this is very common, very natural. Even if you, those who have not yet given their physics exam, if you are solving circuit theory related questions and after solving the entire thing, if you find that answer may be little weird, don't worry, it might be the correct answer. If you have done all the steps correctly, if you have accounted everything properly, then that is very much possible getting a weird answer. Okay, so that is one thing. No holidays for maths exam. How to prepare? Don't worry. Keep practicing. Today is Saturday, so practice maths today. Tomorrow, Monday, I think Mangalore North has physics. So tomorrow you can prepare for physics, and then again prepare for maths whenever your exam is, right? Hello, Shagufta. I hope your question is answered. Yadunandan. Sir, how to take the general equation in general? How to take the general equation in general? So there is no general equation. You have to consider a loop. Individual loop, always remember individual loop. So if the loop has a battery or not. First of all, you have to check the loop that you are considering and try to consider small loops, not the bigger loops. Try to consider small loops, not bigger loops. That is step number 1. Okay, so for example, I have considered this loop and this loop. Also, your loop must contain whatever you are trying to find. For example, I. It is not necessary, but at least in one of the cases, they should include I. Okay. Fortunately, here I is equals to I1 plus I2. Even if you don't consider this loop twice, that is also fine. The second loop that you can consider is the bigger loop. Bigger loop is difficult to manage because there are two batteries. Two batteries are sending current in two different directions. Okay. That's why I always say that. Try to consider small loops and try to see if the circuit has more than two batteries. Okay, if possible, in competitive exam it might not be possible always, but in board level exams and in KCET level exam it is possible that each loop will have only one battery. Okay, so here we will consider this loop because this has only one battery. Second, we will consider this loop because this loop also has one battery. There is another loop that you can consider is the bigger loop where two batteries are there. But that will be complicated. If you don't know the theory, if you have not practiced enough, then you will not be able to do that. So first you have to consider the smaller loops. Okay, then you have to consider this smaller loop. Okay, now each loop, whenever you are considering any loop, try to take the direction of your rotation. You have to go, whenever you start, you have to go throughout the loop in the same direction. For example, you think you started from this direction, then suddenly you decided, no, I will not go in this direction, but I will come in this direction. That is not the way. So you have to go into the same direction throughout the loop. That is rule number 2. So small loops, and each loop try to have only one battery. If no battery, that is best. Okay, for example, in the Kirchhoff's in the Wheatstone bridge principle, if you remember, we consider loops that has no battery. No battery means on our right hand side we can simply write 0. So no battery means that is the best loop, but here any loop you consider, they will have batteries. So one battery is the best loop where you can only consider one battery. Okay, so here we can consider this loop having only one battery, and also we can consider this loop having only one battery. So these two loops we have considered, and always go from the positive of the battery to the negative of the battery. That's why you can write positive of the voltage on the right hand side. So these are the tricks, few tricks. Okay, I will take one exclusive session on how to solve current electricity circuit theory based questions. Do check that out after your midterm is over. Many students requested me in the past, so I will take care of that as well. That will be only exclusively for circuit theory based question, board exam as well as competitive level exam. So everything will be covered in that video. So that will be coming shortly after your midterm exams is over, somewhat end of the October. Okay. Yes, Yadunandan, as I mentioned, we will be bringing up exclusive content for the circuit theory related questions. We will solve more examples, more questions. One example you can practice from is the if you have the model question paper of last year. This year they have not released any model question paper as of yet. So there is one model question paper from the last year. You can go and check that out. I have done that question also, but that maybe you may not find that question right now. You can try to solve it yourself, and later on we can discuss maybe in future videos on solving that. Okay, Yadunandan, right? So but if you follow the basic principles, then you will be your whatever method you use, you will always be correct. So first of all, you have to look for the junctions. For board exams, it is very simple. Even I have seen that there is a very difficult question for unbalanced Wheatstone bridge based question that came, I think, 2024 board paper, first board paper, that is the main paper. There was a question, circuit theory based question based on a Wheatstone bridge, which was very complicated. But the KCL part they have given in the question paper itself. Okay, so how the currents is being divided, which current you have to take I1, which current is I2, how they are getting merged I1 plus I2. So that was given in the question paper itself to reduce the time for you. Okay, now anyway, I think the live is getting longer. There is one more live scheduled at 3:30. I have to conclude it now. There is one more surprise for you coming at 6 o'clock today. So if you get some time, please do join at 6 p.m. live today. All the teachers will be here. And with this note, I would like to, sir, for the last question is numerical value round R we substitute. Should we find the equivalent resistance? Which one? Yes, you have to find the equivalent resistance, which is 52, because it is given as 2 ohm resistance of the inductor and circuit has 50 ohm resistance, so you have to add these two. Okay, but I guess this is a very exceptional question. If you don't do it, they will deduct 1 mark. Okay, so if you don't do it, they will deduct 1 mark. If you do all the steps properly, you get 4 marks if you forget to do that, if you have not done this net. Okay, otherwise series LCR circuit, so the resistances directly gets added to just give you an idea that you have to consider if you are considering any other resistances. Okay, so there will be one more live from 3:30. With this note, I would like to conclude this. Right, if you have any more questions, please mention in the comment section of the main video. Once the video is over, live is over, you can mention in the comment of the main video. I will try and check and reply on the comments itself. Okay, thank you.